Welcome to this week's Training Tuesday, everyone. I'm Heidi Reese, Dayton Superior's Training Programs Manager. I'm real happy that you've come to join us for this Training Tuesday. Just a couple of things to talk about before we get started. Just real quick, everyone who has joined the call has joined as a muted person. However, I don't want you to feel like you can't, be a part of this. So go ahead and either in the chat functionality in Zoom or question and answers, you can ask us a question. You can chat with me as Paul presents, but really we'll have a mini question and answer session at the very end for you. In addition to that, all of the presentations, the webinars are recorded and they're put out there on DaytonSuperior.com's YouTube channel, as well as DaytonSuperior.com's website that points to that channel. So when I send the email out, you know it's good to go. You can forward to someone who maybe couldn't make it. You could rewatch it and make fun of Paul, who's here, and you'll hear about him in a minute.
Feel free.
Or me, my voice is perfect to make fun of. But yeah, so those will be out there. And so what does that mean? That means at everything that we've done, and this is you ready for it? Drum roll, 101 Training Tuesday. Woo. So last week, had I thought about it, I would have had bells and whistles. So I'm sure you're happy that I didn't do that. But just real quick, this presentation that we're about to go over truly is intended for training purpose only. If you want to do anything with the products that we're going to mention, specifically around technical or safety, please go to DaytonSuperior.com and check out the technical specifications, technical data sheets, guide documents, applications, safety data sheets. We've got them all out there on DaytonSuperior.com. So Dayton Superior, we are the leader of engineered solutions for the concrete construction industry. We're here to build the solutions in a single source format, and we do provide you accessories, chemicals, forming. But in addition to that, we pride ourselves in engineering and training as well. So what does that mean? That means we have the largest engineering staff on staff, if I can say it again. But really, if you need something along the lines of bridge deck help or precast tilt up, the engineers can assist with that and get you going. Whereas Chuck and myself can handle you for training. Just contact us at training@DaytonSuperior.com and we'll be happy to talk back and forth with you to get more customized training, longer trainings, in-house, lunch and learns, you name it. So let's go ahead and get started with why we're here today. We're going to be talking about epoxy injection techniques for concrete repair. So that's going to be along the lines of, okay, what do we want to do? We want to look at it. We want to figure out, should it be fixed? Can it be fixed? And then prep the surface and ways to inject with the procedure. And then, of course, how can Dayton Superior help? And today with us, like I already mentioned, and he already talked, he spoke to us.
I'm here.
Is Paul Monin. He is our technical support specialist here at Dayton Superior. He's a graduate of Ohio University and has grown up working in the construction supply business. I mean, he was probably really small running around his dad's store with all of the everything, the goop.
5'10", 120 pounds.
Yeah, there you go. His professional experience includes a wide variety of industry topics and expertise, such as working as an environmental health technician and both inside and outside sales positions that effectively provide consultations and great customer experience. One of the reasons that he is now part of Dayton Superior is because he's so good at that, and we want to allow him to work with our customers to help with technical support alongside the rest of the chemical team. In addition, we can't forget his past data analytic position that has provided him with those skills to deliver specifications and lead assistance to you, as well as the overall arching understanding of the business behind the scenes, because he's done past warehouse management and shipping and receiving. So he's very well-rounded. He's here to help you with technical, and he's here for me today to do epoxy injection resin. So have at it, Paul.
Thank you so much for the introduction, Heidi. Thanks everybody for tuning in. Happy Training Tuesday. Again, my name is Paul Monin. I'm a technical service support specialist, something like that, at Dayton Superior. And we're going to talk about epoxy injection techniques for concrete repair today. Before we get into the weeds, I wanted to point out a couple of documents in particular, especially the ACI RAP Bulletins 1 and 2. American Concrete Institute has gone through the research and basically standardize everything structural concrete related that there is to regulate and standardize. These two documents are very detailed, very comprehensive in how they address epoxy injection techniques. And if you need any information on these documents, if you'd like us to talk about any of this, feel free to reach out to us for more information. So the first step to epoxy injection is deciding if you need to inject. I like going over these kind of preliminary steps with all of our chemical products because no chemical solution is a one size fits all, flex seal or whatever, slap the flex tape on the tank of water and it just stops. Like there's more research required in any job than just like putting down a chemical and calling it a day. So it's really important to understand why the concrete is cracking, to understand if there's any structural issues, especially with elevated decks, post-tension, pre-stressed concrete. If you're working on a foundation, a lot of these applications are in foundations. If you need any kind of information about structural repair, make sure to consult with an engineer. The only way we can prevent future cracking and future issues is to understand the full issue and to take a comprehensive approach to repair. So if you're ever dealing with a vertical crack or a horizontal crack in concrete, no matter how wide it is, make sure you're getting a good look at the crack and understanding why there's movement in the concrete so that you can fix the issue permanently and not do something that's going to be ineffective in the long run. So once again, we have to decide whether or not epoxy injection is an appropriate structural repair technique on a situation by situation basis. The primary usage of epoxy injection techniques is for hairline cracks or small thin width cracks in concrete that penetrate into the slab or go through a wall and where you're not going to be able to get a trowel down in there. You aren't going to be able to use a cementitious repair mortar to get it in the crack and rebond things that way. You need something smaller, thinner, lower viscosity. That's why these injection resins have become so popular. If the crack does not compromise the integrity of the structure, there are other options as far as injectable materials, polyurethane grouts, things along these lines. We are going to cover all that today. We're talking about structural repair epoxies. And, on a case-by-case basis, these can be very handy tools in your toolbox in terms of repairing structural concrete. So selecting an injection resin is actually very simple if you think about epoxies in terms of viscosity. Basically, the smaller the crack, the lower viscosity epoxy you're going to want to use to repair the concrete. So you can see here all these numbers on the left come straight from ACI documentation. For hairline and 1/8 inch or lesser width cracks, you're going to need something very low viscosity, almost water consistency, that's going to be able to find its way into the crack with pressure, or in a gravity fed application where you can just feed it into the crack vertically, gravity's going to do its work. For very thin cracks, hairline, 1/8 inch kind of cracks, we need something super low viscosity, super runny. And as you get wider in cracks, you can use higher viscosity materials. If you're looking at a 1/4 inch crack, a medium or a gel viscosity may be more suitable. So just on a case by case basis, a crack by crack basis, if you will, just need to know what you're doing and pick the right material for the right job. If you ever have any questions, if you're looking at an injection resin job and you don't know which way to go, feel free to reach out to us. We do this kind of stuff all the time, and we are happy to guide you along your way.
Well, you do it. I don't do it all the time.
Yeah, Heidi will be happy to pick a product for you. She'll sign a letter saying it's going to do its job and everything.
No, I do too.
Yeah, I think we'll do that, but it's all good. So once again, case by case basis, we're looking at different epoxies for these injections. We have essentially 2 workhorse injection epoxies that we run out. 50 is the lowest viscosity. It is almost water consistency. This is really good stuff for thin hairline cracks or gravity fed repairs. It's moisture tolerant, it's chemical resistant. Epoxies are very good at tolerating moisture, tolerating chemicals. Their service temperature and service life is very, very high. Meets ASTM C881, which is your basic epoxy epoxy bonding regulation. It's a very, very low viscosity, very easy to inject, comes in cartridges. So you can inject it with a pneumatic or an electric or a manual 2-component caulking gun. Or if you want to get it in 3-gallon units, if you have a big injection job, you can get it like that and put it into a pump. Propoxy 100 is very similar. It's not quite as low viscosity. Therefore, we specify it for slightly wider cracks if needed. But I don't want to call them interchangeable, but in a lot of cases, you can use either one. The really big benefit of Propoxy 100, if you had to kind of pick one of these to ride with most of the time, unless you need to get into a very hairline crack kind of situation, in which case you want to move to Propoxy 50, is that Propoxy 100 has been tested and is certified for NSF 61, which is potable water, a regulation that comes into play in a lot of scenarios, particularly with wastewater treatment plants. Wastewater treatment plants are notoriously huge drivers of concrete volume. A lot of times there are injections that are needed there over time for maintenance. In that case, Propoxy 100 is NSF 61 certified. That's your ball game right there. That's your boy. I don't know what I'm saying today. A little word jumble. Good stuff though here. Very important as well. Surface preparation is probably the most overlooked and most important part of any concrete repair job. Things need to be clean for things to adhere to concrete, putting it as simply as possible. So all these recommendations and all these criteria on the left here have been outlined by ACI. If you're coming on an epoxy injection job and you know you're going to need to do a cap seal, you're going to need to set ports, you're going to need to inject epoxy into the concrete, you need to make sure the concrete is clean. Clean the concrete. It's like my mantra, clean the concrete. A 1/2 inch wide on either side of the crack is what's recommended. Wire brushing is arduous and it's annoying and it's laborious, but it's the way we recommend doing this. Mechanical means grinders, anything like that, you're creating a ton of dust. Dust gets into the crack. Dust rises into the air, it settles back down, and then it's still in the crack. You haven't gotten rid of anything. Vacuum is your friend. Shop vac is your friend. Wire brush is your friend. Get rid of all the loose concrete on either side of the crack. If there's any contaminants in the crack, anything that might cause bond breaking issues, address that with compressed air or a vacuum. If there are any really deeply embedded grease or oil stains and you're going to be doing an injection, please reach out to us. We'd like to talk you through some different means by which you can get oil and grease out of the concrete to make sure that the epoxy adheres. If the surface of the crack is deteriorating, like if you were to knock on it lightly with a hammer and you're getting chip outs on either side, ACI and we recommend that you V-groove the crack using a crack chaser wheel, 4.5 inches, normally gets it done, to provide a mechanical profile by which the cap seal can adhere and to make sure that we aren't bonding basically not structurally intact concrete to epoxy. You're going to create a big mess doing that. It's not going to work in the long run. It's not a good situation. So basically, before you inject, set a cap seal, V-groove the crack, clean the concrete, make sure there's no dust, contaminants on the surface, so that way the epoxy can stick to the concrete. Once again, with drilled in ports, another thing, you're drilling into the concrete, be mindful of dust. A lot of these cracks that go deeper into, especially on vertically facing concrete walls, require mechanical port drilling. But if you're going to have to do that, especially if you're going a couple inches into the concrete, just be mindful of the fact that you're going to be creating dust and you have to get that dust out of there before you inject the crack. Otherwise, what's typically going to happen is the concrete cementitious dust is going to kind of fuse with the epoxy resin as it's setting. And a lot of times you're going to gum up your caulk gun, or if you're using a port, or if you're using a pump, rather, your pump will gum up and you'll be putting more and more pressure, and you're going to be getting less and less material going out at the end because the cement and the epoxy have created this kind of gelatinous, stiff, non-moving substance that's just bad. So if you can avoid drilling in for ports and just use surface applied ports, that makes it a lot easier. We sell them. There's a picture on the left of what they basically look like. A little plastic cylinder with a cap. You can see that on the right of the port that's on that picture right there. And basically on a vertical surface, you're going to be going from bottom to top, and you're just going to be capping those ports as you go. The resin will leak out as you've gotten into the crack and you've gone into the wall, and just kind of climb up the wall with those ports, keep capping, and next thing you know, you're done. It does go very fast actually when you start moving this stuff. Port spacing is kind of tricky. I've seen a lot of different numbers thrown out in terms of, 4 inches, 6 inches. I think kind of a good rule of thumb is that it's going to vary a little bit based on the width and depth of the crack. Basically, all we need to do is make sure the epoxy is getting where it needs to go. Guys who've been doing this for a long time have a good feel for it. And once you've kind of started working with these materials, there is a little bit of a feel that goes into port spacing. Basically, you just want to make sure that you're covering the entire crack and you're getting into the entire crack. You want to make sure that the back side of the crack is sealed, especially in vertical applications with subgrade applications. A lot of times this stuff is not accounted for. It's very important that you know where the epoxy is and isn't going. So I'll get off my soapbox and stop that tangent. We're not going anywhere. But in any case, you need to seal the entire crack, because if you don't, the injection resin is going to find its way out of the wall somewhere. And it starts with cap sealing. Before you inject, you seal the caps and you set your ports. A cap seal is generally a structural anchoring adhesive epoxy. We'll get into a few Dayton Superior products that fit the bill later. So basically what we're doing though with the cap seal is sealing the crack from the outside so that we can set ports and inject into the crack, and the epoxy does not run out the front side of the crack where we are injecting into. Basically, this material needs to be non-sag, it needs to be stiff, it needs to be moisture tolerant so that it can deal with a little bit of hydrostatic pressure, and it can deal with the pressure that's going to be put on it in the injection cycle. Working life is important. You need to make sure this stuff's going to hold up for as long as you need it. It needs to be super rigid. It needs to get super hard. Otherwise, the epoxy is just going to find its way back out of the wall. It's not going to work. If you're using a cartridge and you're doing your cap seal, it's a lot like vertical caulking. Just draw a bead. If you need to smooth it out, you can smooth it out with a putty knife or another steel slicking tool, customary to the caulking business. And you can see what this looks like on the right. This looks like a concrete tank. This photo's from the aughts, if I had to guess, probably 2000, 2005 or so. Dayton's been around a long time. We have a lot of old photos. I like them. This is what it's going to look like. You can see they got the cap set. They have their port set. They're ready to inject. It doesn't get much simpler than this. This is what it's supposed to look like. Basically, you have to have your cap go a ½ inch on either side of the crack to make sure that your epoxy is not going to leak out the front end of the injection site. It's recommended that the cap seal is applied at 3/16 of an inch. That's ideal. Not all of them are. The big reason that they're recommending that you apply 3/16 of an inch of epoxy for your cap seal is so it's thick enough to take on the pressure of the injection. Clean surface, ½ inch on either side, 3/16 inches thick. And then you're going to be ready to go. You're going to be ready to inject. The cap seal should hold up. This is what it looks like when the cap seal doesn't hold up. So you can see on the left here, you have a port that's been set with a cap seal epoxy, and they didn't get all of it. So you start injecting into the crack, and eventually you have that resin running back out. I'm not exactly 100%, 100,000% sure what's going on the right here. It just seems like they didn't put enough epoxy over the crack. Because you can see it's just leaking out the front end of the cap seal. They are pumping in epoxy. You can see the hose there running into the crack. And this resin is just coming right back out. That's what it looks like when you have a cap seal failure. If that's what's happening, I just say shut everything off, let everything set, and address it, next. You're gonna have to figure out why this epoxy is running through the crack, and you're gonna have to seal it up in order to inject it properly. Cap sealing materials, we have them. Propoxy 300 Fast is probably the most popular. We have a slower setting variation in Propoxy 300 and a cold weather variation in Propoxy 400 as well. I don't want to confuse you too much with numbers. Just know that we have anchoring epoxies that are ideal for cap sealing. Propoxy 300's fast setting, non-sag, moisture tolerant, VOC compliant, very popular anchoring epoxy. It's great for cap sealing. It's very easy to work with. It sets up really fast. It's available in single cartridge or double cartridge tubes, or if you're working on a big job, you can always get it in gallon units and it will do the job. Once again, back to NSF 61, wastewater treatment plants. Pro Anchor Elite has been tested and is approved for NSF 61. So if you're getting into a big injection job where potable water and water contact is concerned, Pro Anchor Elite is going to be our selection for that. Also available in a variety of units. As far as injection procedure goes, after your cap seal is set, after your ports are set, after everything is ready to go, reread the technical data sheet.
Always, always, always.
Always. I work in technical services. What else do you expect me to say? But mixing epoxies and pumping epoxies, it's a job by job thing. If you've used one, you haven't used them all. So make sure you're mixing in accordance with the manufacturer's technical data sheet. Double check your cap seal and all of your ports before you start injecting. If you have done this before, a quick look is probably going to be what you're going to need. Just look at everything. Make sure you're not seeing the side of the crack. Make sure you're not seeing any weird angles where you can see into the crack from any side of the cap seal. Make sure that the ports are set well and that there's no issues with gaps between the ports and the concrete like we saw in that one photo with the cap seal failure. Start at the widest section of a horizontal crack. So basically wherever it's biggest, that's where you're going to start if you're working up or down. And if you're working from a vertical plane, start from the bottom and work your way up. And that's going to be basically how it goes. Here's another picture of a gun. And you're going to inject until refusal. That's how you know you've injected the entire crack without X-ray vision or any other superpowers I'm not aware of. Eventually the material is going to stop feeding, or you're going to have all your ports where it's coming back out, all of your ports, you've capped all your ports. At that point, you're done. As long as there is not epoxy coming out the back end of the crack, which is super common, especially in residential applications. So if you work in the residential world and you do a lot of subgrade foundation work, it's best to have a good look at the outside of the house before you start injecting epoxy. Otherwise, the epoxy could all end up on the other side of the other end of the wall. So once again, continue injecting until refusal into the ports. If you're going from port to port to port, the adjacent port will start bleeding. You're going to cap that port, cap the port you're on, move the next port. Eventually, you're going to run out of ports. It's simple as that. Hairline cracks, they can be finicky. They may require increased pressure. I do want to say, though, one step at a time as far as increasing pressure on your pumps. We don't want to just go gung-ho and blow everything out. So just slowly increase the pressure in the case of a hairline crack, and eventually you'll get there. Here's another old photo. This one looks like it's from the 80s or 90s. I love this guy. He's just perching. I don't know what he's even standing on there. It doesn't.
Probably a countertop.
Probably a countertop.
So this is a non-safety feature, right?
Yeah. We like to talk about safety a lot here, and this guy is not playing it by the 21st century books here. But this is what it looks like, you know, it's nothing fancy. We have a crack and an overhead vertical plane. He has a pump. You can see there's two sides, A and B, the metal containers. The pump is bringing pressure and bringing the injection resin up into that crack. He has his cap seal. He has his port set. That doesn't look like it's going to be too bad. Now this, on the other hand, whew, this is kind of a mess. I like this photo a lot though, because it shows you what happens if you don't find the entire crack on a wall. You start injecting, you set your caps, you have all these ports set, you have your cap seal set. And next thing you know, down at the bottom there on the bottom right, you can see resin's just running out of the wall. That is the definition of a hairline crack. They didn't even see it when they set their cap seal. So if you ever see that start happening, once again, I just recommend turn off the pump, stop shooting, just let everything, you know, fizzle out there for a minute, readdress. Looks like they're going to need to go back and set some more ports and seal off the remainder of that crack down there so that they can get full penetration of the injection resin. Because if it's running out the front side of the wall, it hasn't gone the whole way through. Science. Finishing touches. A lot of this stuff is sort of architectural, and if once again in residential applications, you know, somebody's going to want a clean basement wall after they've had their wall injected. Pardon me, I can't talk today. But chipping or grinding is good to remove the cap seal. If you ever need to check the repair, core samples are really the best way to do that. There are all kinds of new fangled technology machines that I don't really know a whole lot about in terms of impact echo and ultrasonic pulse velocity. There are a lot of ways to check and make sure that the repair has been done. If worse comes to worse though, and you need physical evidence, core sample is the way to go. But ultimately, if water stops coming through the wall, that normally means you've fixed the deal. And this is what it looks like when you're done. That's the same wall as that mess of an installation with
the hairline.
with the hairline. Yeah.
Awesome.
So yeah, you grind off all the epoxy, the cap seal, and you can see they came back there. It looks like they used something kind of like maybe a lighter tinted version of Superior wall finish.
I wonder what that is.
Yes,
I think we have a training Tuesday on that.
Oh, do we? Yes, we do. But yeah, thin set repair mortar just to, you know, architecturally make that look good. But that's what you're going to do. Get all that epoxy off there, get the ports off there, refinish the wall. Good to go. If you have any questions while you're working on a job like this, feel free to reach out to us. Here's our website. Here's our tech services phone number. Me or Nathan or Bill or Jeff, we're happy to help you with anything you need.
So to talk about it, we have a lot of technical service representatives that are here to help you out there in the field. But in addition, we obviously have Paul here back at home, and we have our product manager and the director of all of it. So we've got a great chemical team is what I'm trying to get at here. And DaytonSuperior.com, I started the presentation with get out there all of our documents. It's true. We have product pages for everything. Just search on the product that he either spoke about today or that you just want to see. There's a search feature in the top right that you can plug in, and you can get to that information. And on those product pages, you'll find all the good stuff, whether it's DOT approved, it'll shoot you off to a map to verify BABA. I mean, all kinds of great things. LEED, if you need LEED type of certificates or numbers. I can't remember the name that they call it.
I'll send you them.
Just everything is on that page with the documents that you need for that product. I was looking at the custom training. That's why I said training. So there's a QR code there that if you want that custom training, meaning you want to hear more than just the epoxy small slice version of injection resin, maybe you want a whole entire epoxy presentation from one of our nice chemical guys and gals, then we can provide that to you as well. So while you're getting those questions in there, I want to thank you for coming. Please put your questions into the question and answer session. I'm so glad this is recorded because we can come back and hear all these blah, blah, blah.
We're really struggling to talk today.
It's too pretty outside. I don't want to be
It is very nice.
But I think we have one. Let's see.
Yeah, what's up?
Oh, if I was wrong about you've got one on your
I saw that.
computer. Let's see. Okay. No, we're actually good, but are there any questions? Going once? Going twice? We got a minute, so I'll give you just a second to type in.
If you have any questions that come up later, if you, if you're driving or anything right now and you don't have the opportunity to type that in, you're always welcome to email me. My name is Paul. My last name is Monin, Monnin, PAUL, MONNIN at DaytonSuperior.com. If you have any questions that you can't, you don't feel comfortable typing in the chat, or you don't have the
It's just me, although I do say it to the world, but yeah. All right, everyone. Yeah, Paul's here for you. All of us are here for you. And I'll get the email out to you. I had one person ask about the presentation. We don't provide those outside of the Dayton Superior group. However, everything, like I said, is recorded. And so you can get out there and listen to us hemming and hawing as I'm doing right now. I want all of you to have a fantastic Tuesday, and I hope to see you next week. Thanks, Paul.
Thank you.